Hi, my name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury, and this video works out a normal distribution problem, the normal distribution of continuous distribution. It's the type of problem you will undoubtedly see in a basic probability and statistics class, and you'll also see them again in mathematical statistics class. And these are the type of problems that arise in everyday real life, in business and in not in business, just in life in general. If you run across, you can use these problems for a lot of situations that arise in life. Well, this is a problem that I started in the first video. This is the second video number 2 on the normal distribution. There will probably be about 6 or 7, maybe even more videos on the normal distribution. And here's the problem. An amount of money requested on loan applications at a bank is normally distributed with a mean of 400,000 and a standard deviation of 120,000. An hour ago, a loan application is received. What is the probability that? And we had parts A and B on that. Part A said, what's the probability the loan application will be for more than $500,000, and we worked out that problem in the prior video. And part B asked what's the probability the loan will be for an amount between $450,000 and $500,000, and we worked out that probability. So now here in part C, we're saying this. We want 5% of the loan application. We want to know what value will be the cutoff point where 5% of the loan applications will be greater than or equal to this amount. So, according to the problem, we have a mean mu of $400,000 on these loan applications, and we have a standard deviation of 120,000. Let's draw a picture, and I think that I can explain it in here a little bit better. As you should know by now, I'm a terrible artist. So we have the mean of 400,000 here. We're interested in this right tail, and it's saying, look, this tail should contain 5% of the applications. If that's the case, what is this value right here that represents the cutoff point where every loan application over that is in this 5% of the tail region? So the mean has a z-value of 0, and we're going to find out now what the z-value is for this point. And let me show you how we're going to attack this problem. We know that our z transformation equation is x minus mu over sigma. In the prior problems, we knew x, we knew mu, and we knew sigma, and we calculated z. Here, we're going to find z. We can do that now. We know that the tail contains 5%. Therefore, this region contains 45%. So we're going to go into the back of the textbook. We're going to look for the area in here of 0.45. Well, 0.45 happens to be between 1.64, which is 0.4495, and 1.65, which is 0.4505. In fact, 0.45 lies directly in between these two areas. Therefore, the z-value associated with this area, 0.45, is 1.645. So this z-value is 1.645. Now, given that, we can now calculate a value for x, which is missing. And let's do that now. So we know that z is the z associated with a cutoff point of 0.05 is 1.645, and that's equal to x, which we don't know, that's the point we're finding, minus mu, which is $400,000, divided by sigma, which is 120,000. If we multiply both sides of this equation by 120, 1.645 times 120 is 197.4, and that's going to be 120 over here, they go out, is equal to x minus 400. We're going to add 400 to each side, gives us 597.4 is equal to x. Well, that's what it turns out to be. 597.4 is the x value associated with this point here, this cutoff point. So we know that 5% of the applications will be for an amount $597,400 or more. So let's take a look again what this problem is. This problem asks us, it says, hey, 5% of the loan applications will be greater than or equal to what amount? We know that $400,000 is the mean. We know that $120,000 is the standard deviation. We know, therefore, that 0.05 is the area of the tail. And remember, in probability and statistics, we associate area with probability or likelihood. So we took our z transformation formula, z equals x minus mu over sigma, mu being the mean, 400, sigma being the standard deviation, 120. We found the associated area with 0.05 in the right tail. That's 1.645. And then that got us to this point. And from here on in, it's an elementary school algebra problem. We solved for x. We multiplied each side by 120, and then we added 400 to each side. We came up with 597.4, and that's the solution to this particular problem. So this was the second video. There's about 6 or 7, perhaps even more, videos on the normal distribution. If you found this helpful, I'd appreciate it if you leave a nice positive comment. And then in the meantime, I wish you all health and happiness, good health and happiness, and see you in the next video. Bye-bye.